Operator overloading is used within a class to specify how your custom object handles math, streaming, subscript, and other operators. Why overload your operators? Well, it's adding functionality. So if you wrote a fraction class with a numerator and denominator, you might want to implement math operators so that it would be easier and cleaner and just nicer code to read. Maybe if you're writing a custom list class, you want to use the subscript operator to quickly access a member of the list without having to call a function. As a quick reference, here's a sample of some of the common types of operator overloading and what they look like in the code. You'll notice that when overloading certain operators, the functions won't be members of the class themselves, but friends of the class. So here, for any sort of addition, multiplication, subtraction, and division, these will be friends outside of the class that operate on two parameters of that class type. You might want to overload relational operators, so you can do comparisons between which one might be greater or less than or equal to or not equal to. You can even overload the stream operator. This way, when you're using the input stream, you can set it to store it in a specific place or places. And when you're using the output stream, you can customize how the class information is output to the screen. If you want to overload the subscript operator, note that it will actually be a member of the class, not just a friend. Also note that the subscript operator does not necessarily need to return an integer. It is whatever the type of data you want to return. The assignment operator is also a member of the class itself. Now with the assignment operator, you'll be able to say which member variables get copied over whenever you're assigning one type of this class to another type of this class. But you will also need to make sure, before you do any copying over, that they are not trying to assign the same class to itself. Otherwise you'll get some problems. A lot of these types of operator overloading can be illustrated with a fraction class, so let's go ahead and implement that so we can see how these actually work. Alright, so we are going to implement a fraction class. Private members would be a denominator and a numerator. And then publicly, if we were just kind of programming this as normal, let's say we have a constructor to initialize the values. So down here we'll have fraction, int n, int d. So we can easily create these fractions and assign values to them. So we'll say f1 is equal, well, we'll say 1, 2, so it is 1/2. So, but what if we want to do something else, like add two fractions together? So this is 3/4. We can't just say fraction sum equals f1 plus f2. It's not going to know how to do this. There is no match for operator plus, because we haven't defined it yet. We would have to write some sort of function like void add and pass in two fractions. So let's put that in here just as an example. We'll just start by writing a function as normal. So we have fraction, we're going to return a fraction. We'll just say add, and we'll pass in two fraction references. And we'll create a result. And we don't have any way to like set the denominator and numerator at the moment because it's not a friend. So let's say that these are friends. We'll go ahead and just say this is a friend fraction add, and we'll put the declaration here. So now we should be able to say result dot im numerator. Well, first the denominator is going to be the common denominator, and we'll just do this lazily by saying it's the denominators multiplied together. So we're not reducing the fraction at all. We're just kind of doing the rough addition. So the numerator would be the first numerator times the second denominator plus the second numerator times the first denominator. And then we would return the result. So we still can't do add, what is it saying? No call, oh yeah. We don't have a constructor at the moment that just takes nothing in. So we'll say fraction, fraction, and if they don't initialize the fraction, let's just set the numerator and denominator to 1 and not 0, because again, if the denominator is 0, that could cause problems. So, okay. Initialize it to 1, doesn't really matter, we're going to override it. We still can't use this plus sign. No, what's it about? Did I miss a... Oh, result return. Return result. Okay, and then over here, instead of doing it this way, we could say fraction sum is equal to add f1 and f2. While we're at it, maybe we should just write a display function as well. So void display. And it will just see out the numerator, and then a slash and denominator. And we'll have to go ahead and include IOStream and all of that. So include IOStream using namespace std. So we'll add this, and then let's say sum.display. So first let's start with like 1/2 and 1/2. I'll erase these comments. We'll run it 4/4. Well, it multiplied these even though they have a common denominator anyway. So 4/4, that's right. Let's say we have 2/4, 8/8. Okay. So that's a basic add function. We can actually very easily turn this into the plus operator, and we will do that next and add all of the different math operations. Okay, so to actually turn this into the plus sign, instead of saying this is a function named add, we'll say it's a function called operator plus, and that's really all we gotta do here. So we can say f1 plus f2. If we build it, look, it works! It works! It's as simple as that. So we can do the other math operators, multiplication, division, and it's going to be about the same. So subtraction is going to be pretty close, multiplication is going to be a lot more easy. We'll just have numerator 1 times numerator 2, and division. So I believe this would be numerator 1 times denominator 2, and denominator 1 times numerator 2. So let's create some different math for each of these. Let's say sum, difference, product, quotient, and we will display these. So we'll do sum.display diff prod quotient. So let's just make this maybe 3/5 and 3/5 or something. I'm not sure what would be easiest to look at. Oh, and I named these different, so let's say A and B. Okay, so 25, 25, it'd be 15 plus 15 is 30. Subtraction would be 0. 3 times 3 is 9, and 25, and so that's probably okay. So that's basic arithmetic. What if we want to compare two fractions to see which one is bigger? Well, the relational operator is a little bit similar. Let's go ahead and say friend fraction. Oh, not that. Sorry, that was for the math ones. If we want to do a inequality, it'll return either true or false. So are they equal? Are they less than or greater than or whatever? So we'll have operator double equal sign, and we'll pass in two fractions. Then down here, let's put this here. We don't need the friend keyword in the definition. And then we can compare the two fractions. So if we don't want to give them the same denominator, maybe we'll just test to see return item 1 dot numerator is equal to the denominator of the other one, or sorry, numerator of the other one, just basically to make sure that they have the same numerator and denominator. So we can return this. This is a Boolean expression. We could say if this, then return true, otherwise return false, but that's really redundant. We can literally just say return this Boolean operation and it will either return true or false. So let's say is A equal to B. So if A is equal to B, else we'll say true or false. Oh, and it needs a semicolon. True, they are equal. But what if this is, let's say we have 1/2 and 2/4. Run it. But they are technically equal. They just don't have the same numerator and denominator at the moment. So let's make this a little bit more sophisticated. Let's say we're going to have a common denominator for both of these. So common 1 and common 2. We will set this equal to, we'll have, well, we can do multiplication between fractions now, so we can say item 1 times, and remember to get the common denominator we need to multiply both the numerator and denominator by the other denominator, so we basically have to make a new fraction. I know this looks kind of confusing. We'll go over it in a moment. Okay, so 2 and 1. And then we'll return now if common 1's numerator is equal to common 2's numerator and common 1's denominator, common 2's denominator. So if I build this, it'll run. Basically what this is doing is we have this fraction and we want to multiply it by the denominator of this fraction, and vice versa here. So this would be easier to show on paper. So just as a refresher, all I'm doing is, let's say we have 1/2, and we want to say, is it equal to 2/4? Now, this would reduce normally, you would want to change this to 1/2, but what I'm doing is just the really lazy programmery way. To get a common denominator, and that's just by multiplying both by the denominator of the opposite, so 4/4, and then we'd have 2/2, and then that would give us 4/8, and again 4/8, and then we're comparing it. So here we're creating a new fraction. It is equal to the first fraction multiplied by a new fraction, and the new fraction is just the denominator of the second fraction. Or the denominator over denominator, which is essentially equal to 1. That's what's going on here. And then after we have these two new fractions with common denominators, we're comparing them to see if they're equal or not. Okay, so now we can say, are these equal? When we run it, it will be true now. And then if they're just different fractions, it will say they're false. So another thing we might want to do is also implement the other inequality operators. So we can have not equal to, maybe I should put these stacked, and we will expand this. So not equal to, we'll have less than equal to, greater than equal to. So let me move this back up here now, and we'll do the same here. So not equal, less than equal. So essentially for the logic behind not equal to, we can just say return the opposite of item 1 is equal to item 2. So we'll pass, this will automatically call this, it'll check if they are equal, this will return true. So this would be equal, if they're equal it will be true, but then we return the opposite, so then it would return false, not equal. Okay, so here we still want the common denominator, and remember, once we have a common denominator, we can compare these. So I should have put that on a different layer. Let's say we have two common denominators. One is 1, one is 2. Whichever one has, let's see, which one's bigger? Well, the one with the higher numerator. So once we have the common denominator, we can do the same thing. We can return, is item 1 less than item 2? Well, is item 1's numerator less than item 2's numerator? Numerator. And then likewise for this one, we can say return, it'll be true either if it is less than or equal to, so if item 1 is less than item 2, or item 1 is equal to item 2. So then our greater than will be pretty similar. We'll have greater than equal to, and we'll just use the greater than sign for comparison. Okay, so let's see if this will build. It will build. Let's change this around to do some comparisons now. So relational, well, let's do one more thing before we get into that. I want to overload the stream operator so that we can easily display these fractions with the cout statement. Still with me? So, time for the stream operator. Now, the stream operator will be a little interesting because we can implement it in different ways depending on how we want it to work. So let's go ahead and say we're going to create a friend class. Its return type is going to be OStream if we're doing an output stream. I spelled that wrong. And so note that cout as well as the OFstream class are both family members of the OStream class, so we can just pass around OStream and we could use cin, cout, well, not cin in this case, we would use cin for iStream, but cout or an OFstream object. So operator, that stream operator, we are going to pass in the stream that we're currently using and whatever fraction item we're currently working with. So that's a little weird looking, but let's go ahead and implement this. That's the thing there. And again, no, we don't specify friend in the actual definition. So if we're streaming out, we basically can decide however we want it to look. What we're going to do is stream out to the out parameter, and then we're going to return the out parameter when we're done. So we take in the out parameter and we return the out parameter. So we'll probably be using this with just cout for now. But let's say we want to output a fraction. Well, let's say item dot numerator slash and item dot denominator, and no end line because we could be stringing these together. Now remember, like, these are friends, so we can access the numerator and denominator easily. We don't need to use any special getters or setters. It just makes it very easy on us. So now, let's say we want to display, instead of sum.display and all that, like that is kind of ugly. Let's say output A plus B is equal to the sum. And when we run this, oh, I need to include something, so that's the video editor, that's not what you need to see. Okay. Include, let's do iostream using namespace std. Okay. So we'll run this. 1/2 plus 2 halves is 6/4. So all we had to do is write it like, and that's a standard cout statement. So we can go ahead and just output everything here. I have some code already written to display our relational stuff. So arithmetic and relational. You can run it. Oh, this is a function I wrote somewhere else, so let's just copy that function because it just makes it cleaner. If you try to output a boolean, it'll display 1 or 0. Just ignore this for now. It'll just display true or false instead. So, is 1/2 equal to 2/2? No. What about 1/2 and 2/4? So, all of this still works. We have less than, not less than, equal, yes, not equal, false. Okay, but what about the input stream operator? What if we want to input our fraction information with the cin? So let's say iStream, and we will have an iStream in, and we will implement that over here. So whenever they're going to use the cin statement, so we're going to like let the user input something. Let's say we have, those are being initialized, but we want to say enter fraction a. You can say cin a, enter fraction b, and cin b. Then we want something, we want this to handle that. So when we're doing input, we want to get both the numerator and the denominator, so we can string those together and then return it. So again, we're taking in the input stream and returning the input stream. So when we run this now, it'll say enter fraction a. I can enter 1 and 2, I can enter 3 and 4, and it will just handle it normally. And that makes it a lot easier on us. Okay, let's also have an assignment statement. So with an assignment statement, it will return a fraction reference. We'll use the operator equals, and we'll pass in a fraction, another fraction. So we're saying, like, you know, fraction 1 equals fraction 2. Fraction 2 is going to be what's passed in, fraction 1 is what's returned. So copy this, and we'll put that down here. Now, this one is not a friend, it is an actual member of the class. So we will make that a member. When we are assigning one fraction to another, it's important to first check to make sure we're not trying to assign it to itself. So we're checking to see, is this the address? Are they the same address? Because if they are trying to copy between the address from one end, the same address to the same address, that could cause problems. So if they're already equal, just return this thing instead. Otherwise, if that's not the case, we don't need to write an else, because that return statement, it will return, it won't go any further than that if that happens to be true. So we don't need an else statement, but we'll say if we're copying it over, the right hand side RHS is equal, we'll just copy these over. So denominator here and here, and then we will return this. So essentially what we're doing is, for fractions, like C++ doesn't know what makes two fractions equal. We have to tell it that in order for us to assign one fraction to another, it needs to have the same numerator and denominator. So whenever you're creating a just any sort of class and you want to use the equal sign, you have to specify these things are going to be copied over. Then afterwards we are returning, this is a pointer to the memory address of the current, you know, class, whatever the instantiated object is we're using the equal sign on. And then we use the asterisk to dereference it, so we're literally just returning a reference to the same object. So if we build that, what is it saying as left? This, oh, I typoed. Okay, so now instead of doing that, we can say, well, we could say A is equal to B, or we could say A is equal to some new fraction. So either of those will work. We can just kind of pass these things around and do whatever. Okay. Lastly, let's do the subscript operator. It's not a great example for this fraction, but it's something we can do. So for the subscript operator, it's up to us what we're going to return when they pass something in. So if we said like maybe a of 0 would be the numerator and a of 1 would be the denominator, and then everything else might be invalid. This is kind of a weird example for it. Like if we were containing a list of fractions, we might want to return a specific fraction. If we're making a special list object, we would return a special, whichever items at that element, at that index. But for the fractions, let's just say 0 and 1 are numerator and denominator, and then everything else is invalid. So it's up to us to return whatever kind of object we want to return. It can be an int, it can be an int reference. I'm going to return an int because I'm going to return an actual numerical value if it's invalid. So we'll say fraction, it'll be operator with the subscript const int index. So this is also a member of the fraction class. And so we'll need to use the scope resolution operator here. And we will say if index is 0, we'll return the numerator. Otherwise, if index is 1, we'll return the denominator. And otherwise, we're going to return -1. Just because, again, a fraction isn't the greatest example for doing this, but it's something we can do as an example for here. So let's say numerator is a0 and denominator is a1. So if we run this, enter fraction a, 2/3, 3/4, and then we can access each one separately. So let's move all these into one window. This is an example of different ways we can overload our just operators. There's more operators. We could overload the increment or that operator. There's a ton more. These are kind of the most useful. The most, like if you were writing special like a vector type or a fraction type or different things that contain numbers that might need to have math done on them, this would be really useful for that. So here's our math operators, arithmetic operators. Here's our relational operators, our stream operators, assignment, and subscript. Kaveh, what do you think about operator overloading?